two problems here, sorry. The first one is telling us that there are 25 flowers, 11 were white, 5 red, 3 are blue, rest were yellow. The empirical probability that a flower will be yellow, well, empirical means out of the data you have. So um, there are 25 flowers, take away 11, 5, and 3. And what's that? Well, 11 and 5 is 16, plus 3 is 19. That leaves a total of 6 flowers left. 6 out of the 25 flowers are yellow. So that means you have a 6 out of 25 empirically picking yellow. 6 being the number of things you're looking for, and 25 always being the total number in the trial. That's all empirical probability really is. In this next one, they want to draw a tree diagram that represents the types of sandwiches we can make here with one of each ingredient. So you can have a white or a rye to begin with. Then you could pick ham or turkey or beef. In both cases, ham, turkey, and beef. Then you can always pick American or Swiss, right? So we have these different combinations that we're mapping out here. And we're just, the tree diagram helps you quickly tally up all the different ways, right, to make a sandwich here. Determine the number of sandwiches that will not include turkey. Well, turkey is a type of meat, and you can see it here and here. So that's 4 sandwiches right there that will not have turkey. So in total, there are 2, 4, 6, 8, 10, 12 ways to make a sandwich, or 2 times 3 times 2. And so I'll put that here. There are 12 sandwiches, and 2 of them, two of these mid-level branches don't have turkey, but those connect to 2 final sandwiches with American and Swiss, right? So that's 4 different sandwiches will not include turkey. Types of sandwiches. Determine the number of sandwiches that will include rye and Swiss. So rye is automatically half the grid, right? But we need rye and Swiss. So it's rye and Swiss, Swiss, Swiss. So that's 3 cases. Over here, there's no rye, but there is Swiss, but we need both. So there are 3 sandwiches out of all the sandwiches here, the 12 that have rye and Swiss. Okay, what's the probability that a dart will land on the bullseye? So the bullseye is this central area right here, and they're labeling the radius. It's 2 inches. So the area of that circle is radius squared, so 2 squared times pi, out of the total area of this dartboard, which is 9 squared times pi. So we divide these two, in other words, the small bullseye out of the total, and what's going to happen? Well, the pi's cancel out. You have 2 times 2 over 9 times 9. Well, here, can we cancel anything out? Well, let's see, they did have 4 over 81 here, and I'll choose that one as a choice, right? So that's your probability, and it's right here, 4 out of 81. Okay. Storage bins contain color blocks. Bin 1, okay, contains 15 red and 14 blue. That's bin 1. Bin 2, let's see what this is, contains 16 white and 15 blue. And bin 3 contains 15 red and 15 white. All the blocks from these bins are placed into one box. If one block is randomly selected, what color would be most likely to be picked? Excuse me. So we add them all up. We have 30 plus 31, so 30 plus 31 plus 19. Okay, so 30 and 31 is 61, plus 10, 71, plus 9 is 80. So in total we have 80 here. Which color would most likely be picked? Well, the color with the most. So we have 15 red and 15 red over here, so it's 30 red, 15 white, and 16 white is 31 white. And then the blue, we have 15 and 14, or 19 blue. Okay, so here just the most popular in this case was the white, so that would be most likely to be picked. Okay, keep going. Alright, a large company must choose between two types of passwords, and the first type is a four-letter password using any of the 26 letters of the alphabet without repetition, and the second type is a six-digit password using 0 through 9 with repetition. Alright, determine the number of possible four-letter passwords. Okay, well, the company is choosing between two types of passwords, and the first type, right, they're choosing one or the other, would have 26 letters, the alphabet, so regular alphabet, and we are looking for four-letter passwords. Okay, and that 26 letters of the alphabet it includes repetition of letters. The second is, sorry, I'll read it again, a six-digit password using 0 through 9 with repetition out loud. So let's do that one first. The number of four-letter words. Okay, in the first case, there are 26 letters. I'm sorry, I mean this over and over again. But it says without repetition, so you can't reuse them. So first you can pick 26, and then 25, and then 24. So for each 26, there were 25 choices, and 24, all the way down to 23 because we're only allowed them to use four-letter words. So, when we got the calculator, we have 26 times 25 times 24 times 23. We get 350,800. Okay, and then here in the second type, we're looking for six-digit passwords, and we can have repetition. So each time there are 10 digits to choose from. In total, there's 6 digits, so it's 10 to the sixth, or 1 million. All right, so that certainly is a better way to serve the employees to allow repetition. Right, it creates so many more passwords. The company has 500,000 employees. Okay, and a different password for each. State which type of password the company should choose. Explain. Well, you need to at least pick the one with a million plus choices because here the other one would have a million codes to choose from. So a lot of people have the same passwords, and that's not something you really want. Right? It's definitely a breach of security. Okay. Okay. The probability that it will rain tomorrow is 1/2. The probability, so that's the probability of rain tomorrow. The probability that our team will win, the probability of our win is 3/5, which expression represents the probability that it will rain and that our team will not win the game. So the probability of raining is 1/2, and not winning is 2/5, right? Because the probability of winning is 3/5, that has to add up to 1. This is just an estimate. These twos cancel out, you get 1/5, but they want to see the equation. So you have 1/2 times 2/5, choice 4. Okay, so with this company, first place, right, that's $15,000 in cash. So they want to draw a tree diagram for this, so it's 15,000 first prize. Second prize could be motorbike, trip, or more cash. Third prize is a choice of television, so TV, or more cash. Okay, so I'm just outlining this, TV, cash, and then, oops, TV, and cash. So you get 2, 4, 6 ways, and they want to know the number of ways all three prizes could that all three prizes likely could be cash. All right, so you can get 15,000, and then here on the second step, you can put cash, and then cash again. So that's one way. Another way is here, and another way is there. So there are 3 different ways to pick cash here. Turn out of ways that none of these 3 prizes selected could be cash. Well, if there are 3 selected where there could be cash, then there should be 3 that are not, right? And there's TV, TV, TV. There are 1/2 of the total each.